right, so we have our trapezoid area formula, base 1 plus base 2 times the height, all divided by 2. These are usually pretty easy to work with. So why don't you guys go ahead. We don't have an example of this on your note sheet. Oop. I think that's my lunch. Guess I'm skipping lunch today. That's okay. Anyway, y'all go ahead and try this one with the formula and then check your answer here. So pause this, try it out. And correct answer here is C. So if we look at our formula and we write it out, base 1 plus base 2 times the height, all divided by 2. You'll see with this, it's pretty simple because they give you everything that you need. Here's your bases, base 1 and base 2. So we add those together, just filling that in there. So 30 plus 25 times your height, which they give you is 11, all divided by 2. That simple. All right. How about area of a triangle? Most of us know this formula, so this one's not anything too new. But go ahead on your formula, wherever you're putting your formulas, put area of triangle. And that formula is base times height divided by 2. That one also comes from the parallelogram formula. Most of these do. So you can easily turn a triangle into a parallelogram if you make 2 of them, right? Now we have a parallelogram. So if you simply do your base times your height, that will give you the area of that whole parallelogram, and then dividing by 2 gives you just the one triangle. Here you go. So base times height divided by 2. The hardest part with triangle area is simply finding the height. Okay, if you're given a right triangle, those are super easy because your base and your height are just the 2 legs, because they already have a 90-degree angle for you. So you would just do this times this divided by 2. Now if you have any other triangle where you don't have a right angle, this would be your base, and then you'd have to find that height and then divide by 2. So that can be a little tricky. Okay, adding to our area formulas, go ahead and write both of these down. Here's the area formula for a rhombus. I would simply put area equals and then write what I have circled right here, which is diagonal 1 times diagonal 2, all divided by 2. Rhombus and kite are not too bad because they have the same area formula. So again, for a kite, write this one down on your little formula sheet. Diagonal 1 times diagonal 2 divided by 2. These are pretty easy to work with. Both for a rhombus and a kite, they involve the diagonals. Now, a rhombus is also a parallelogram. So you could also use just the base times height if they give you enough information. All right, so let's look at some examples involving these. So this one is on your note sheet, example 2. It says find the perimeter and area of a rhombus with a side length of 13 and the length of one of its diagonals 24. All right, so you got to kind of remember some properties of a rhombus. It is a parallelogram where all its sides are congruent. Okay, so I would start with maybe just drawing a rhombus like I have here and then labeling anything they give you. So a side length of 13, that can go anywhere. Just put that over here. Okay, and the length of one of its diagonals is 24. Now we don't know which diagonal, and it really doesn't matter, so I'm just going to pick this longer one right here. Since it's a parallelogram, diagonals bisect each other, so instead of like labeling the whole thing as 24, I'm just going to call this part of it 12. You can label that one too if you want. Okay, so if we think of our area formula for a rhombus, it's diagonal 1 times diagonal 2 divided by 2. So you need the lengths of both diagonals. Well, we only have the length of one full diagonal, but I bet you can figure out a way to find this length. Now, one other thing you may have forgotten about a rhombus is diagonals are perpendicular. So look what we have here, a little right triangle situation. So you can do some Pythagorean Theorem to solve for this side, and then just double it, and you got that whole diagonal right there. So let's do a little Pythagorean Theorem off to the side. So we can do 12 squared plus, let's just call this b, plus b squared equals 13 squared. Go ahead and simplify that on your own. Simplifies down pretty nice. We end up with b equals, so you end up taking the square root of 25, so b equals 5. Keep getting interrupted by that bell. All right, so if b is 5, then this is also 5. So now we know diagonal 1 and diagonal 2. Let's go ahead and write our area formula equals d1 times d2 all over 2. Fill in everything in now. One of my diagonal lengths is 24 times, of course, this one is now 10. All divide by 2. Go ahead and do that math. Actually, let me go up on this one. We get our area equals 120 square units. I didn't include that. Of course, they didn't give us units. Now, I did say find the perimeter. So that part's pretty easy. If this is 13, you're just doing 13 times 4. So perimeter, we get 52 units. Okay, I got another example down here. Hopefully y'all can see all of that. Little kite problem says one diagonal of a kite is twice as long as the other diagonal. The area of the kite is 90.25 square inches. What are the lengths of the diagonals? Okay, let's start with just writing the area formula for a kite. d1 times d2 all over 2. Okay, let's see what we can fill in here. They actually give us the area in this problem, so let's actually plug that in. So area is 90.25. All right, let's see what we can call these diagonals. It doesn't give us the actual length of either one, but it does tell us one of the diagonals is twice as long as the other one. Now, if you just name one of your diagonals, like let's say one of them is called x. Okay, well, the other one I could call 2x, right? If one diagonal is twice as long as the other one. So that's what I'm going to do. So I've got one diagonal, some number x times 2 of those, all over 2. Let's go ahead and simplify that. We could multiply both sides by 2, so this goes away. So we get, that would be 180.5 equals, now we got x times 2x, which would give us 2x squared. So let's simplify. Okay, solving for x, divide both sides by 2. So this goes back down to 90.25 equals x squared. Go ahead and use your calculator. Take the square root of that number. Let me flip this around. So we end up with x equals 9.5. So the question it asks us is, what are the lengths of the diagonals? So both of them. Well, if x is 9.5, that was one of our diagonals. The other one's going to be 2 times x, right? So final answer, we could say 9.5 and 19 would be the lengths of the diagonals. Okay. So that covers all of the basics with area of all the different quadrilaterals that we talked about. Last thing we're going to look at is some areas within circles. Okay, so first thing is something called the area of a sector. Now, on your formula sheet right now, I would write down this right here, area of a sector, and go ahead and write this down. So what in the world is a sector? So a sector is, it's got the formal definition in your notes, but basically it's just a pie piece of a circle. Okay, so just a part of the whole area of a circle. And they'll usually just have that shaded in for you and call that like sector CMD. Okay, so you'll notice the area of a sector, this formula looks a lot like the arc length formula. Okay, they're really, really similar. The only difference is, so whenever we did arc length, we usually set up a proportion, like